This is Professor Pelton. This is Trigonometry Chapter 2, Section 2. We're doing the other types of graphing of trig functions. It's going to cover tangent and cotangent. So we did the outline of tangent and cotangent in the prior video. So the idea is every half pi, tangent is going to repeat with asymptotes, and every whole value of pi, 0, 1, 2, 3, 4 pi, the asymptotes will exist for cotangent. Okay. However, those values will change based on the b and c values. Okay, they're going to shift left or right, or spread farther apart, or come closer together. Okay, and the point in between is always at 0, and the halfway points are always at 1, which is the a value. However, that a value is not always 1; it can increase or decrease. Okay. All right. So let's try this out. Okay, so tangent is typically between half pi values for the asymptotes are. But this one has an x over 2 plus 0, so that means the b value is 1/2 and the c value is 0. So if I just simply multiply everything by 2, I get negative pi is less than x is less than pi. So that gives me the new interval for a single cycle of tangent, which is between asymptotes of negative pi and positive pi. So that total distance is a period of 2 pi in either direction. So halfway in between them 0, and halfway between each of those I should be at 1 normally, but since it's a multiplier of a times 2, I'm at 2 and negative 2. So it looks like just like the standard tangent graph, except it's scaled accordingly. Okay, I can go out another 2 pi, so 2 pi to 3 pi is another 2 pi, and repeat the process. Okay, and last cycle. Okay, so the domain is everything except the whole values of pi, that are odd, of course, because the evens aren't going to, because at 2 pi and 4 pi it still exists. So in the odd value of pi, it's not going to exist. The domain, the range up and down goes forever, and amplitude doesn't apply here. That's something that is concerned with sine and cosine. Okay, so for cotangent, typically it's from 0 to pi. Every iteration of whole values of pi we have asymptotes. But this is going to be altered by a 2x minus 0, so the b value is 2 and the c value is 0. So if I just simply divide everything by 2, I get 0 is less than x, which is less than pi over 2. Okay, so at 0 and pi over 2, I get my initial first cycle. So my period here is pi over 2. It's only a half pi cycle. So halfway in between them 0. And halfway between those I'd be at 1 and negative 1 normally. But since this a value is a 3, I'm at positive 3 and negative 3. Because all tangents go up and to the right, and all cotangents go up to the left. Okay? And that would repeat itself in all directions. Okay. Alright, so at the end of the day, what are we doing? We're doing y equals a times whatever the function is, tangent or cotangent, doesn't matter, bx minus c, and there's the d. The d didn't really apply here, so that's going to affect the points that are not 0, and that's going to affect our size of the cycle accordingly for either one of those. So bx minus c. Okay? Alright, pause the video, try the student problem for yourself. Okay, so tangent is typically every iterations of half pi. Alright, so if it's every iteration of half, oops, sorry, we forgot to put the 2x in there. Let me move that down. I apologize. It's 2x plus 0, because the b value is 2 and the c value is 0 here. So we'll just multiply everything by a half. So that gives me negative pi over 4 is less than x is less than pi over 4. So that gives me iterations starting at pi over 4. I'm sorry, negative pi over 4. I said that backwards. It ends at pi over 4. So that is our initial first cycle. So halfway in between I'm at 0. And halfway between there is to be an eighth. I'm going to be at 3 and negative 3. That'll give us our initial first cycle. And that can repeat, of course, in either direction. So if you think about it, we're going from pi over 4, 1/4 in one direction, 1/4 in the other direction. So the period is a pi over 2. It's every half pi, basically. Okay, and you could repeat that. You can go to 3 pi over 4. Okay, and negative 3 pi over 4. And repeat those cycles. Okay, let's try the cotangent. So cotangent has cycles of pi. It's here every whole pi. But this one's pi over 2 x plus 0, which means b is pi over 2 and c is 0. So I'm just going to simply multiply everything times 2 over pi. So that'll give me 0 is less than x is less than 2. So that means we don't even need pi iterations numbering on our x-axis. So it's simply just going to go from 0 to 2. We just have a period of 2, a whole number. So halfway in between is 1, I'm going to be at 0. And halfway between those, which is a half and 3 halves, I'm going to be at 1/2 and negative 1/2, because that is our a value. And tangent goes the other way. And that repeats itself, going in all directions. Okay, let's try some more. So in these next ones, the c value is not 0. They have been 0 for the first 4 problems. So in these ones, they're not 0. Okay, so the same thing happens every half pi. You get periods of tangents. This one is x plus pi over 4, so I'll minus pi over 4 from all sides. Oh, I don't know why I put a divide sign there. That is incorrect. So basically the b value is 1 in this case. The c value is 1. And a value is 1, b value is 1, but the c value is negative pi over 4. Okay, so if I subtract 1/4 from a half, I get negative 3/4. Oh, I wrote that backwards. It's less than x is less than, alright, so you have a half minus 1/4 is 1/4. Okay, so at 1/4 we have an asymptote, and at negative 3/4 we have an asymptote. So that gives me a period. So 3/4 in one way, 1/4 the other way. Subtract those, you get a 1 pi or 4/4 iteration for a cycle, right? Okay, so halfway in between would be negative pi over 4, and it's 1 for the a value, so it's 1 halfway in between there, negative 1 the other way. And those cycles repeat. If you'd like to draw them in, we'll skip them though. Just put the initial cycle. Okay, so cotangent goes from 0 to pi, and we have x minus pi over 4. So add pi over 4, add pi over 4, add pi over 4. So 1/4 is less than x is less than 5 pi over 4. Okay, or 1/1/4 pi. Alright, so that is our initial first cycle. So pi over 4 and 5 pi over 4. Okay. Alright, so halfway in between would be 3 pi over 4. And it's a 1 for the a value this time, right? It's a 1 right there. So we're at 1 and negative 1. Okay. So as far as the period, how much is it in this case? Well, we're going 5/4 in one direction, but we're losing a fourth on the other, so that's really a pi period, isn't it? Is 5 pi over 4 minus 1 pi over 4 is 4 pi over 4. Right? So basically every iteration of pi will give you a cycle. So 1, 2, 3, 4. You can repeat that process, 1, 2, 3, 4, to get you the next iterations if you want them. Just making sure those periods are of size pi. Doesn't quite fit on there, but that's okay. Alright, so, and over here, the period's a pi also, so make sure it goes whole pi. And 1, 2, 3, 4. They don't fit on here nicely, but that's fine. Some of the end ones will be cut off. But typically you only want to put a couple cycles anyways. You don't need to keep going forever. Okay. Pause the video, try the student problems on the next page. Alright, so tangent is every half pi for the asymptotes. And this time we have x minus pi over 2. So I'll simply add pi over 2 to all sides. So we get 0 is less than x, which is less than 1 whole pi. So we have a 0 to pi. So the period is simply 1 pi for one cycle. So halfway in between at pi over 2 we're at 0, and then our a value is 1, so we're at 1 and negative 1 for the points halfway between there. Okay, and we can repeat yourself every pi. And continue the pattern of tangent at 0, 1, and negative 1. Okay, alright, let's try the cotangent. So cotangent repeats every pi for the asymptotes. But we have an x plus pi over 2 here, which means a is 1, b is 1, but c is negative pi over 2. So minus pi over 2. So this tells us that every half pi we have asymptotes here. So we'll put in our half pi asymptotes. Okay, so halfway in between we're at 0, and since a is 1, we're at 1 and negative 1, the respective other halfway points. And we're going to repeat that because our period here is pi, because I go half one way, half the other. That's a whole pi, right? So we can do whole pi cycles now. Got a little cut off here on the end, but that's fine. We just won't be able to repeat. We won't be able to finish off the cycles on the end because we only have half of it. As over here, now I did the second half, or the first half, however you want to look at it. And same thing here. Okay? Alright, that is the end of this part.